Welcome back. We love getting into the nitty-gritty of research here, and today we're taking it into a topic that is, well, let's be honest, it's the bedrock of any good master's level research project.
Absolutely. We're talking research design.
Yep, research design. And we're going to be pulling some wisdom from two big names in research methodology, Cathari and Matthews.
So consider this your one-stop shop to really get a handle on how to build a solid blueprint for your research, especially if you're working on that master's thesis.
No better time to think about it than right at the start.
Exactly.
So let's not waste any time. Let's break it down. First things first, what is research design, like at its core?
Okay, well, you can't talk research design without mentioning Cathari, right?
Yeah.
He kind of lays it out as think of it like the arrangement of all the conditions you're going to need for collecting your data and then how you're going to analyze it.
Okay, so it's not just like, I'm interested in this, so I'm going to, go look at this. There's actually a lot of thought that has to go into it before you even start.
Oh, absolutely. I mean, it really is the roadmap for your entire research journey. From the very beginning, like defining your research problem, all the way to how you present your findings. It's all got to be in there.
So it's a plan.
It's the plan.
That makes sense.
And actually, to get even more specific, Cathari breaks this whole process down into 10 really specific decisions that you need to make.
Okay, 10 decisions. That seems like a lot to think about.
It can be, but they cover everything. I mean, we're talking about the type of data you're going to collect, where you're even going to find that data, how are you going to make sure it's good data, how are you going to analyze it, what are you going to do with it? It's comprehensive.
That's wild. I bet some of those seem obvious. Like, I don't know, what is this study about?
Right, exactly.
But some of them, I'm looking at this list and it says, what is the control design? I mean, what does that even mean?
That's a good one, right? So control design, basically that's all about figuring out how to manage all those, extra little variables, those things that could mess with your results, even though they're not actually what you're trying to study. And at the master's level, this is huge. You don't have unlimited time. You don't have unlimited resources.
Right.
You got to be really smart about how you design your research, and controlling for these extra variables it's like non-negotiable if you want to get solid results.
Right. So if you're not controlling for that, you may not even be measuring what you think you're measuring.
Exactly. You could be attributing a change to something when it's actually something completely different that's causing that change.
Okay. So before we get lost in all the weeds of the specific designs, can we just take a step back and really drive home why we even need research design?
Right.
I mean, especially for a master's student.
Right. Yeah. No, that's super important.
Because like you said, you're busy, you're under pressure. Why spend all this time on this step?
Well, Cathari actually lays out some really good benefits. Like the first one, think about bias.
Okay, bias.
Right.
Right. Like, we all have our own biases, but in research, that can be a problem.
It can be a huge problem. And a well-defined research design, that's how you minimize that bias. That's how you make sure it's not sneaking in and messing with your data. And then the other big one, reliability. You want your data to be solid. You want to know that if someone else did the same research, they'd get similar results. That's reliability.
So is that kind of the idea, that you want to make sure that you're not just getting lucky with your results, that it's actually, there's some consistency there?
Exactly. You don't want to be, putting all your eggs in one basket and finding out later that it was just a fluke.
Right. You don't want to build your whole thesis on a foundation of sand.
Exactly. You want that solid foundation. And honestly, a good design, it can be a lifesaver for a master's student. It's all about getting the most out of your time and effort, right?
Yeah, absolutely. Because like you were saying earlier, like master's students, we're not just researching. I mean, maybe some are lucky enough to just be researching, but I mean, you've got classes, you've got, maybe a job, you've got other commitments, life is happening.
Right, you're juggling a lot. And a strong research design helps you maximize what you can learn with the limited resources you have. That's crucial when you're on a deadline.
Totally. So it's like, working smarter, not harder.
Absolutely.
Okay, so we've established research design is important. It's essential even. But now let's talk about some of those, I guess, like key concepts that we're going to keep coming back to as we go through this whole thing. And the one that jumps out at me, of course, is variables.
Of course, yeah. The building blocks of research.
Right. And I vaguely remember this from undergrad, but, it's been a while.
Yeah.
So what are they?
Well, simply put, variables are anything that can change or vary. Cathari makes a big deal about the difference between dependent and independent variables.
Oh, yeah, right. Okay.
The dependent variable, that's what you're trying to figure out. It's the outcome, the thing you're interested in. The independent variable is what you think is affecting that outcome.
Okay, so let me see if I can get this right. If you're studying, let's say, how exercise affects stress levels would be your dependent variable.
You got it.
And then exercise would be the independent variable, the thing you're changing to see how it affects stress.
Exactly. You're getting it.
Okay, that's starting to make sense. But then there's extraneous variables too, right?
Oh, yes, those pesky extraneous variables. Always got to watch out for those. They're the variables that can sneak in and mess with the relationship between your independent and dependent variables.
So like in our exercise example, maybe someone's diet is also affecting their stress levels, but we're not really accounting for that.
Exactly. That's why you need to have a good control strategy in your design.
Okay, control.
Mm.
So how do you control for those extraneous variables?
Well, there are a bunch of different ways, and that's actually where all the different types of research designs come in. Each one has its own approach to controlling for these confounding factors.
Got it. So the design you choose is going to depend on what you're trying to study and what kind of control you need.
Exactly.
Okay, before we get into all of that, can we just really briefly touch on the different types of research designs, just so we have a big picture in mind before we dive into the details?
Absolutely.
Cathari talks about three main categories, right?
He does. You've got exploratory, descriptive, or diagnostic, and then hypothesis testing.
Okay, so what's the deal with exploratory studies? What are they all about?
Think of those as the initial, scouting missions in research. They're perfect when you're dealing with a topic that hasn't really been studied much before. You're kind of going in blind and you want to get a feel for what's there.
Okay, so it's about figuring out what you don't know, basically.
Yeah, it's about generating some ideas, some hypotheses, some research questions that you can then dig into later on with more focused research.
Okay, makes sense. And then what about descriptive or diagnostic studies?
So descriptive studies are all about painting a clear picture of, well, something. It could be a situation, a population, a phenomenon. You're trying to answer what questions?
Okay, and what questions? So what are the characteristics of this group of people? Or what is happening in this particular context?
Exactly. You're describing, you're diagnosing, you're getting a deep understanding of what's going on.
Got it. And then finally, we have the hypothesis testing designs.
Right. And those, like the name suggests, are all about testing out specific predictions. You have a hypothesis, you're trying to figure out if the evidence supports it or not.
So that's where you're really trying to prove something or
Yeah.
disprove something, I guess.
Exactly. And these hypothesis testing designs, they're super common at the master's level because you're expected to really dig deep and look for those relationships between variables.
Okay, that makes sense. So we've got our three main categories: exploratory, descriptive diagnostic, and hypothesis testing. But I'm guessing there are even more specific types of designs within each of those categories, right?
You bet there are. A whole bunch, actually. But before we jump into all of that, can we take a quick detour and talk about something that's really important in those descriptive diagnostic studies?
Oh, sure. What's that?
It's all about the tools you use to gather your data, specifically the difference between structured and unstructured instruments.
Okay, structured versus unstructured. I'm intrigued. What's the difference?
So structured instruments are things like surveys with those nice, neat, multiple choice questions. They make it easy to collect lots of data that you can then analyze pretty easily.
Okay, I see. So it's all about that standardization, making sure everyone's answering the same questions in the same way.
Exactly. But then you have unstructured instruments like open-ended interviews. They can give you a lot more rich and detailed information, but they can be a lot trickier to analyze because everyone's answers are going to be different.
Right, right. So it's about choosing the right tool for the job, basically.
Exactly. And that's a decision you'll need to make early on in your research design process.
Okay, this is all starting to come together now. But before we move on, can we just circle back to those 10 research design decisions that Cathari talked about?
Yeah.
Just to make sure I'm really connecting all the dots here.
Oh, absolutely. Let's break them down one by one.
Great. So the first one, what is the study about? I mean, that seems pretty straightforward, but how does that connect to everything we've been talking about?
Well, that's where you're defining your research problem. You're figuring out what you want to study and why it matters.
Okay, so it's about getting really clear on your research question.
Exactly.
And then the second one, why is this study being made? I feel like that's closely related to the first one.
It is. It's about explaining why your research is important. What are you hoping to achieve with this study? What gap in knowledge are you trying to fill?
Okay, so it's like the so what of your research. Why should anyone care about this?
Exactly. You've got to convince people that your research is worth doing.
Okay, makes sense.
Yeah.
And what about the third one? Where will the study be conducted?
That's all about your research setting and the people you're studying. Will you be doing this in a lab? Will you be out in the field? Who are your participants? How will you find them? All of that comes into play here.
Right, because the setting can really affect the results of your study.
Absolutely.
So we've got a research problem, our rationale, and our setting figured out. What's next?
The next big decision is all about the type of data you need. Quantitative data, qualitative data, or maybe a mix of both.
Okay, what type of data is required?
Yeah.
That makes sense. And I'm guessing the next decision follows pretty naturally from that, right?
It does. Once you know what type of data you need, you've got to figure out where you're going to get it from.
Where can the required data be found?
Right. Okay. So are you going to be collecting new data yourself or using data that already exists?
Exactly.
Okay. So now we've got our data sorted out. What's the next decision we need to make? The next one is all about time. What period of time will the study cover?
Okay, time. Right. So are we talking about a snapshot in time, or are we looking at changes over a longer period?
Exactly. That decision is going to depend a lot on your research question and the kind of phenomenon you're studying.
Okay, that makes sense. So now we're on to number 7. What will be the sample design? This seems like a really important one.
Oh, it is, especially when you're thinking about whether your findings can be applied to a larger population. Your sample design, that's where you figure out how you're going to choose your participants from the larger group you're interested in.
Right, because you can't always study everyone in the population you're interested in.
Exactly. So you have to be really strategic about how you select your sample to make sure it's representative of the larger group.
Okay, so it's like you're trying to create a mini version of the population that you're actually able to study.
That's a great way to put it.
Okay, so what's next on our list of big decisions?
Number 8, what techniques of data collection will be used?
Okay, so this is where we're actually getting into the nitty-gritty of how we're going to collect our data.
Exactly. Surveys, interviews, experiments, observations. There are so many different ways to collect data, and you have to choose the methods that are best suited for your research question.
Right, and I imagine that decision is going to depend a lot on the type of data you're collecting and the resources you have available.
Absolutely.
Okay, so we've collected our data, now what?
Now comes the fun part, analysis. Decision number 9 is, how will the data be analyzed?
Okay, so this is where we're making sense of all those numbers and words and turning them into meaningful results.
Exactly. Are you going to use statistics? Are you going to dive into qualitative analysis techniques? That all depends on your research question and the kind of data you've collected.
Right, because the way you analyze your data is going to shape the story that your research tells.
Exactly. And then, finally, the last decision on the list. How will the report be prepared?
Okay, so that's all about how you're going to communicate your findings to the world.
Exactly. How are you going to write it up? How are you going to present it? That's all part of the research design process as well.
Wow, this is really making me think about all the different pieces that go into designing a good research project. It's more than just like picking a topic and starting to collect data. There's so much planning and thought that goes into it.
It really is like building a house. You wouldn't just start laying bricks without a blueprint, would you?
No way. You'd end up with a pretty chaotic and unstable structure.
Exactly. And your research project is no different. You need that solid foundation, that blueprint to guide you.
Okay, I think I'm starting to get it now. Research design is like the foundation of a good research project. It's the plan, the blueprint that helps us make sure our research is rigorous, reliable, and ultimately meaningful.
You got it. All right, so let's get into the specifics now. Let's talk about the different types of research designs you might actually use for your master's research.
Okay, sounds good.
We'll start with experimental designs because they're all about testing hypotheses, which is a big part of what you're doing at the master's level, right?
Yeah, definitely.
These designs, they're all about figuring out cause and effect. You manipulate an independent variable and see what happens to the dependent variable. You're really trying to isolate the effects of one specific thing.
Right. Trying to control everything else so you can be sure that it's that one thing that's causing the change.
Exactly. And Kothari, he talks about these 3 core principles of experimental design: replication, randomization, and local control.
Okay, those ring a bell. Can we just quickly go over those again just so we're all on the same page?
Sure. So replication, that just means doing the experiment multiple times.
Okay, so it's not just a one-off thing. You're trying to make sure that your results are, like, consistent.
Exactly. The more times you repeat it and get similar results, the more confident you can be that your findings are actually real and not just some random fluke.
Right, like if you flipped a coin 5 times and it landed on heads every time, you might think, maybe this coin is rigged.
Right. But if you flipped it 100 times and it was pretty close to 50 heads and tails, you'd be more likely to believe that it was a fair coin.
Okay, so replication is all about increasing our confidence in the results.
Exactly. Now, randomization, that's all about how you assign your participants to different groups in your study. You want to do it randomly so that you don't accidentally introduce any bias.
Okay, so it's like if you're studying the effects of a new teaching method, you wouldn't want to put all the students who are already good at math in one group and all the students who struggle with math in another group.
Exactly. You'd want to mix them up randomly so that the groups are as similar as possible, except for the teaching method they're receiving.
Right, because if you don't do that, then you can't be sure if it's the teaching method that's causing the difference in their performance, or if it's just that one group was already better at math to begin with.
Precisely. So randomization helps you make sure you're comparing apples to apples, so to speak.
Yeah, like that. Apples to apples.
Now, the third principle, local control, that's a little bit more nuanced. It's basically about grouping your participants based on certain characteristics that you think might influence the outcome.
Okay, so in our teaching method example, maybe we group students by their age or their previous grades in math.
Exactly. That way, you can control for those variables and be more confident that any differences you see are actually due to the teaching method and not those other factors.
Got it. So it's all about minimizing those extraneous variables as much as possible.
Exactly. Now, Kothari, he uses this great example of testing the effects of two different varieties of rice.
Okay, I'm listening.
So imagine you're trying to figure out which variety yields more grain, right? To apply these principles, you'd first make sure you're planting multiple plots of each variety. That's replication. Then you'd randomly assign each variety to different plots of land to account for variations in things like soil fertility, that's randomization. And then you might group the plots based on soil type, so maybe some are clay soil and some are sandy soil. That's local control.
Okay, that's a really clear example. So these 3 principles were like the foundation of any good experimental design.
Exactly.
But there are like different types of experimental designs, right? Not all experiments are created equal.
Right, and the one you choose is going to depend on your research question and the kind of control you need. Kothari and Matthews, they both talk about a bunch of different types, but let's start with a couple of the simpler ones. Before and after studies, and after only with control designs.
Okay, before and after, that sounds pretty self-explanatory.
It is. You measure something before you introduce the treatment, and then you measure it again after the treatment.
So you can see if there's been a change.
Exactly. But the problem is that other things could have happened during that time period that might have also affected the outcome.
Right. So like if you were studying the effects of a new stress reduction program on employees and you measured their stress levels before and after the program, but during that same time, the company also gave everyone a raise.
Uh-huh. Right, exactly. You wouldn't know if the decrease in stress was due to the program or the raise.
Or maybe it was just the holidays and everyone was feeling less stressed anyway.
Exactly. That's why you need a control group. That brings us to the after only with control design.
Okay, so what's different about that one?
In this design, you have 2 groups. One that gets the treatment and one that doesn't.
So like one group gets the stress reduction program and the other group doesn't.
Right. And you only measure the outcome, the stress level in this case, after the treatment has been given.
Okay, so then you can compare the 2 groups and see if there's a difference.
Exactly. And if the group that got the treatment has lower stress levels than a group that didn't, then you can be more confident that it was the treatment that caused the difference.
Makes sense. But what if the 2 groups weren't really that similar to begin with? Like what if the people in the stress reduction group were already less stressed out?
That's a great point. And that's why random assignment is so important. You want to make sure that the 2 groups are as similar as possible on all the other factors that could be affecting the outcome.
So you're trying to create those apples to apples groups that we talked about earlier.
Exactly.
Okay, that makes sense. So we've got before and after only with control. What are some of the other types of experimental designs?
Well, those are let's call them the more basic ones. They're good for a lot of research questions, but sometimes you need something a little more, well, robust, something that gives you even more control.
Okay, I'm ready for the next level.
All right, let's talk about completely randomized designs. CR designs for short.
CR designs. Sounds fancy.
They're actually not that complicated. It's all about that random assignment we were talking about. You take your participants and you randomly assign them to different treatment groups. That's it.
So everyone has an equal chance of ending up in any of the groups.
Exactly. And that helps to minimize any bias that might be introduced by, the researchers or the participants themselves.
Okay, I'm following. But what if your participants are really different from each other? Like, what if some are older and some are younger, or some have more experience with something than others? Doesn't that make it harder to compare the groups?
It can, and that's where randomized block designs come in, RB designs.
RB designs, okay. What's special about those?
Well, in an RB design, you first divide your participants into blocks based on some shared characteristic, like age or experience. Then you randomly assign participants within each block to the different treatment groups.
Okay, so you're sort of creating these mini groups that are more homogeneous, more similar to each other?
Exactly. And that helps to control for the variability that might be caused by that shared characteristic. It makes your comparisons more precise.
Got it. So it's like if you were planting those rice varieties again, you might first divide your plots of land into blocks based on soil type, and then randomly assign the varieties within each block. That way, you're controlling for the soil variability.
Perfect analogy. You're getting it.
This is making a lot more sense now. So we've got CR designs and RB designs. Are there any other types of experimental designs we should know about?
Well, there's one more that's worth mentioning, but it's a bit more specialized. The Latin square design.
Latin square. Okay, that one sounds, I don't know, kind of mysterious.
It is a bit unique. It's particularly useful when you have two major extraneous variables that you need to control for at the same time.
Two at the same time. Okay.
Yeah.
So it's like we're playing research design Tetris now.
Yeah.
Trying to fit everything in perfectly.
Kind of. Think of it like a grid where each row and each column represents a level of one of those extraneous variables, and then each treatment appears only once in each row and each column.
So it's like a Sudoku puzzle or something.
Yeah, exactly. It's a really elegant way to make sure that each treatment is exposed to all the different combinations of those two extraneous variables.
Okay, that's pretty cool. I'm starting to see how much thought goes into designing a good experiment. It's like a whole science in itself.
It really is. And we haven't even gotten to factorial designs yet.
Oh, yeah, I've heard of those, but they always sounded really complicated to me.
They can be, but they're also incredibly powerful. They let you study the effects of multiple independent variables at the same time.
Multiple. Okay, so instead of just looking at like one teaching method, we could look at the teaching method and the class size, and maybe even something else like the time of day the class is held.
Exactly. And you can see how all those variables interact with each other.
Interact? What do you mean by that?
So you might find that a new teaching method works really well in small classes, but not so well in large classes. Or that a certain type of homework is only effective for students who are already motivated to learn.
Okay, so you're not just looking at the individual effects of each variable, you're also looking at how they work together, how they combine.
Exactly. You get a much more complete picture of what's going on.
Wow, this is pretty mind-blowing stuff. But I have to admit, it's a lot to take in. Are we done with experimental designs yet?
We are for now, but remember, this is just the tip of the iceberg.
There's more.
There's always more to learn. There are other types of research designs, too, that are important for master's level research, like quasi-experimental designs and non-experimental designs.
Okay, well, I'm ready for a break. Can we come back to those later?
Absolutely. We'll dive into those next. Okay, so last time we were talking about all these different experimental designs and how they help us really nail down cause and effect relationships, but sometimes you just can't run a true experiment.
Right. Like ethically, sometimes it's just not possible to manipulate the variables the way you need to for a true experiment.
Exactly. Or sometimes it's just not practical, like you can't randomly assign people to different living situations or jobs or things like that.
So what do you do in those cases?
Well, you might use what's called a quasi-experimental design.
Quasi-experimental. Okay, that sounds kind of like almost experimental, but not quite.
Yeah, that's a good way to think about it. You're still trying to study relationships between variables, but you don't have the same level of control as you would in a true experiment.
Okay, so how do they work? Like, what's different about them?
Well, often you're comparing groups that already exist. Let's say you're studying the effects of a new school policy on student achievement.
Okay, yeah.
You can't randomly assign students to different schools.
Right. You're kind of stuck with the groups that are already there.
Yeah. Exactly. So you might compare schools that have implemented the new policy to schools that haven't. But you have to be really careful to make sure those groups are as similar as possible in other ways that could affect student achievement.
So, like, you'd want to make sure that the schools are comparable in terms of things like socioeconomic status of the students, the quality of the teachers, the resources they have available, all of that stuff.
Exactly. You've got to try to control for as many of those extraneous variables as you can, even though you can't do it through random assignment.
Okay, that makes sense. So quasi-experimental designs, they're like the next best thing when you can't do a true experiment.
They are, and they can be really useful in a lot of different situations, especially in applied research.
Okay, cool. So we've talked about experimental designs. We've talked about quasi-experimental designs. Is there anything else?
We do. Let's talk about non-experimental designs.
Non-experimental. So not experiments at all.
Right. Sometimes your research question isn't about figuring out cause and effect. Sometimes you're just trying to understand something better, to describe it in detail, to explore people's experiences.
Okay, yeah, I can see how that would be important too.
And that's where non-experimental designs come in.
Okay, so what are some examples of those?
Well, one of the most common ones is the survey design. I'm sure you've taken plenty of surveys in your life.
Oh, yeah, definitely. Like online polls, customer satisfaction surveys, those kinds of things.
Exactly. Surveys are a really great way to get a lot of information from a lot of people relatively quickly.
And they can be used to study all sorts of things, right? Like attitudes, beliefs, behaviors, demographics.
Pretty much anything you can ask a question about.
Right, right. Okay, what else? What other non-experimental designs are out there?
Another really important one is the case study.
Okay, case studies. I've definitely heard of those. What are they all about?
So with a case study, you're really focusing in on one particular person or group or situation. You're trying to get a really deep understanding of that one case.
So it's like a really detailed portrait of something very specific.
Exactly. And they're often used in qualitative research, where you're not so much interested in numbers, but you're interested in the richness and complexity of people's experiences.
So it's about getting a really holistic understanding of something, looking at all the different facets of it.
Exactly.
Cool. Okay. So we've got surveys and we've got case studies. Any others?
We do. There's correlational designs.
Correlational. Those are the ones where you're looking at how two variables are related, right?
You got it.
But you're not saying that one causes the other, right?
Yeah.
Just that they tend to go together.
Exactly. Correlation doesn't equal causation.
Right, right. I've heard that before. But sometimes it can be hard to remember that when you see a really strong correlation between two things.
It can be, but it's really important to keep that distinction in mind.
Okay, good point. So we've got correlational designs. What else?
One more that's worth mentioning is the longitudinal design. Have you heard of those?
Longitudinal? Yeah, I think so. Don't those involve, like, following people over a long period of time?
Yes. You're collecting data from the same people at multiple points in time.
You could see how things change over time.
Exactly. They're really great for studying things like developmental trends or the effects of some kind of intervention or program over a long period.
I can see how that would be really valuable.
Mm-hmm.
But they must be really hard to do, right? I mean,
Yeah.
keeping track of people for years and years.
They can be challenging for sure, but they can also be really rewarding.
Okay, so we've got surveys, case studies, correlational designs, longitudinal designs. I feel like we've covered like a whole smorgasbord of research designs today.
We have.
It's kind of overwhelming, to be honest. I mean, how do you even know which one to choose?
Well, the most important thing is to start with your research question.
Right, okay.
What are you trying to find out? What kind of data do you need to answer that question? What's feasible given your resources and the time you have available? Once you have a good handle on those things, the choice of design will often start to become a lot clearer.
So it's not like there's one right design for every research question. It's more about finding the best fit for your specific needs.
Exactly. And don't be afraid to talk to your advisor or other researchers who have experience with different designs. They can give you some really valuable guidance.
Okay, that's good advice. I guess it's easy to get lost in all the details of the different designs, but ultimately it all comes back to your research question.
It does.
All right, well, I think we've covered a lot of ground today.
We have.
Thanks for walking me through all of this. I feel like I have a much better understanding of research design now.
Of course, it was my pleasure. And to all our listeners out there, we hope you feel a little more confident about tackling your own research designs now. Just remember, there's no one-size-fits-all approach. Choose the design that best fits your research question, and don't be afraid to get creative.
Do not forget to like the video, share it with your friends, subscribe, and hit the notification bell for future videos.